Yeah, thanks for coming. And today's topic is about one kind of the vulnerability, which is it's not obvious enough when you research it or when you test it. So if you have awareness of the vulnerabilities, then you are in a good shape, because if you understand what kind of vulnerabilities you can have, then you can mitigate or at least prevent it early. So today's agenda is a little bit about me and what do you need for this tutorial, how to understand the vulnerabilities, and we are going to have a live hacking sessions, 3 live web applications that we are going to attack, if it's possible to say. And then I'm going to show you some kind of a very naive and simple Python Flask code that, in essence, it's quite simple, but it can lead to some kind of vulnerability. And then we are going to explore in the real world how the other professional pen testers or security engineers found and get bounties, specifically for the race conditions. And my name is Shako. I'm a senior software engineer at NordVPN, and specifically I work in threat intelligence team, where we are trying to understand the available threats for our users. I live in Wildau, Brandenburg. It's a bit far away from Berlin, but it's green, nice, silent place that I love my place too. And I also a board member in Azerbaijan Python user community. We constructed the community in 2015, and monthly we are doing some meetings and answering to people questions day to day. And who I'm not a security engineer, and I'm not a security research engineer either. I'm not a pen tester. I have no direct access or abilities to day-to-day hacking. What I am doing in daily life, so we all love Python and we write Python code, but also I propose to change a window of from where we look at the code and add a bit of, I'd say, pepper and the salt of the security notions. So how to be more informed about the security and about the vulnerabilities. So this is me. What you don't need. So no need for any installation, no need for any coding, no need to distraction, no need for the pain. That usually, for example, what I faced also, if I ask some installation and half of the auditory is failing to install something and they're jumping around, and so no need for that. Just focus and ask questions about what you see. You need to have just an interest in security topics, and it starts from simple steps. How to understand vulnerabilities. So if you go back like 15 years ago, there were a little resources to understand and read about the vulnerabilities. You need to be a member, for example, a closed group of hackers, and they do you a favor and give you some PDF to read. But not it's the case now. So if you go to Amazon, for example, for searching for the books, and there's plenty of the books that you can read, and it's easy to read, so it's not heavy books that you are not going to understand. The first one is, for example, Bike Bounty Bootcamp, and the second one, Real World Bike Hunting, is also, so basically how those books are written, you read about the vulnerability, then they gave a sample, then you can possibly find the same thing, or at least understand that this is the existing vulnerability. Resources to practice. This is also my read of the resources, but I like these 4 of them. So Pentester Lab, especially the code review section. So if you don't hear about that, specifically when you do a code reviews, there's a different notion of the code review. It's called security code review. So imagine that somebody with a security focus does your code review day to day. It's a different notion of the feeling. So this one thing is, for example, your unit test passes. I don't know, you have a CI pipeline all green, but then somebody comes and said, yeah, this is not a good, for example, approach or flow because I see a kind of vulnerability here. Then, well, it's a bit painful, but it's informative, and you learn a lot. So pentesterlab.com is really good at code reviews and the API hacking sections. TryHackMe is beginner friendly, and they have plenty of free rooms. What I mean the free rooms, for example, you are interested in SSRF or XSS attacks, right? And you search for XSS, they give you free rooms to check. They walk through basically CTF style, and then you understand, oh, this is the case. Okay, if the XSS, I understand what is it, then that means that I need to learn more GS, and this is go on. So you understand the vulnerability, you want to prevent it, you learn more. The Podswigger, this is a company behind Burp Suite. This is the software that, I don't know, mostly pen testers are using for all kind of tests and attacks. And they have comprehensive real scenarios with explanations. You can go and explore. And one more I really like, the TCM Academy. They have a high quality courses. So they have a lot of things. For example, I don't know, privilege escalation in the Linux. So if it's not for you, you want to understand the mobile vulnerabilities, and you go for the mobile hacking. If you want IoT, you go for IoT. So it's kind of where you see the code, then that means that there's some kind of vulnerability in that. Yeah, that's the basic steps you can do to understand the vulnerabilities. But what is a race condition? There's an advanced talk about smashing the state machine. This is a really like, I watched it 3 times, but still it's a bit hard to grasp. It's the most advanced talk so far about the race condition, I see. Let's just explore one link. So this resource link is important. It's explaining the race conditions. And I'm going to go through the basic ideas. So let's just close this. So race conditions is also categorized as a business flows. So business flow vulnerability. But also it's considered as a vulnerability of, for example, failing of synchronization primitives. It's called, or is your application, you test your application, you wrote your application as single thread, and then you fail to test it in a multi-threaded environment. This is also a type of, I don't know, different kind of stories that you need to read more, and we will talk about more in the later. So basically what we look at when you talk about the race condition, that's the business logic flows. There's something wrong with your business logic, and then somebody comes and try to, for example, submit a discount code several times. And okay, if it's a single threaded, he is going to submit some kind of discount code one time, and then second time you say that, oh, this, for example, discount code is already used. But how about if it's, for example, update the status, the discount code in a database, and this is a millisecond of the time frame. So it's called this lag. The time frame is it's called the race window. You can run, and this is basically where the attacker looks for you. So you understand your critical sections of your application. For example, if it's e-commerce, you add a basket, and then you push, for example, to apply a discount code. And this race window, if it's not properly synchronized, that can lead for the race condition. In a simple essence. Yeah, again, one more time, as I'm not a security engineer and not a domain expert at all, the whole scenarios, what I really look is try to minimally understand the vulnerability and then act against it. So at least some preventive actions. This is more important than imagine that you got hacked and then you fix this, but it's better to harden the life of the attacker. This is the most important thing as a software engineer. But again, if you have a proper this security flow, checks, and other things, you need to have a different team, and also they will help you. They will help you on this. So this rates window we spotted, right? But it's also the application where there are plenty of them. And for example, as a blog post says, that it's like redeeming a gift card multiple times, rating a product multiple times, I don't know, reusing the single captcha, withdrawing, transferring cash, bypassing some kind of rate limit. Also, you can see, for example, file upload vulnerabilities with the race conditions where they check, for example, they first get your file, store it somewhere, and then check for running for some kind of checks. And during this time window, you can attack and upload an arbitrary file, for example. We will see in a I'd say, simple life hack. And basically, when you talk about the vulnerabilities, and if you have a web application, and basically think about that, what is your critical sections in your application? And what we mean by critical section, it's a business valuable critical section. So where, for example, there's a transaction, the money transaction, or I don't know, there's a critical check, there is some kind of update to the database. You spot these places beforehand, and you understand that, okay, it looks like somebody can use it in this time window and in this time frame. Then you try to localize the issue. So you have a big scope, then you add the defense layers. You go backwards to the inside, and you have several defense layers. And for example, one of the layers is against the race condition. But obviously, this layer is not going to fix all of your vulnerabilities. Yeah, this is about the race condition. So in a nutshell, it's not like comprehensive guide. Yeah, let's explore the one scenario. So it's called web shell upload via race condition. It's just quite simple idea, and yeah, basically let's just fire up this lab and try to go through. Yeah. Gosh, yeah. Oh, how I can hide this? Okay, anyway. Let's see. If I don't forget my password, yeah, okay. No, it takes so long. Probably. Yeah, let's wait. Okay, so we have a web application, and we need to go back to our attack machine, and let's explore what was this. So basically, if you see, this is a full functional web application, right? And then it's a blog, and you can view the post. I don't know, it has a my account. So, and it has a user, basically. And when you hit the user, and here the user can update an email, but it has also the upload functionality. So it tries to upload probably its avatar, right? And then if you go to the burp suite, and it has it's intercepted your request, basically. And when you hit the post login, for example, it's a post request, and you can see what kind of what kind of request to send. So basically, it sends a username and a password and a CSRF token. And then in the response side, there's nothing, basically. I'm not sure why, but yeah, probably it's just redirects directly. So this is basically how you intercept user requests. So this burp suite has professional edition and also as a community edition. So you can direct or download the community edition, at least try to understand what you sent and what you got, and what kind of data is a flow. And then you can add an extra checks, for example. One more thing here, talking about request response. Yeah, you need to have a decent contract between your third party or internal applications. So you expect exactly this field, and you send exactly this request. So it's also preventive actions. So no more extra things, no more different kind of flows. Yeah, let's just upload something. I'm trying to understand how it works. So it doesn't mean that you directly hit the web application and you try to attack. You need to understand the usual case. And if you spot the usual case, then you need to you can find, for example, the unusual case. And if we hit an upload, let's just see if it uploads. Cool. No, method not allowed. Okay. But it's here. Yeah. Let's one more time. Okay, the file avatars mountains has been uploaded. Let's explore what kind of upload it is. So it's sending the post request to my account avatar with the data. Probably it's multi-part. It's some kind of form data, yeah. And the file name is mountains JPEG, and it sends the content type, and then it requests back the file avatars mountains JPEG has been uploaded, yeah. So we got a success. It's also good. Let me apply this as well. And I'm going to back to my account, and you see that it's uploaded and it's shown. Then one more thing that we detect that, okay, it stores it in the files, avatars, mountains, JPEG. This is a path of the avatar, so when you access the dashboard, it just gets a request and gets this file for you to show. Okay, the next step, we understand this thing, and as the name of the lab says that, okay, we need to find some kind of vulnerability in the file upload, and this is a shell, and in PHP world, usually it's like some kind of one-line PHP files that you need to upload and see. So what's a shell? The shell for us, in a simple, not Portugal, but and let's see, like, what was the first attack? Yeah, so exploit is just the single PHP run that I need to get a context of the home Carlos secret. Quite dangerous. So when we upload, when we manage to upload some kind of file and it got run by the web server, as soon as your web server has an access to different places in your machine, that means through this shell you can manage the machine. So basically this is how the web shell works. And let's just upload this and see what's going on. Where's my browser? Yeah, here. And basically I need to go to repos and where it was, yeah, here. And the first attack, and exploit PHP. And if we upload it, okay, sorry, only JPEG and PNG files are allowed. Yeah, we expect such kind of things. That there's an extension check. There can be a content type check. I don't know. There can be MIME check and other stuff. But basically, okay, we see the validation. The one thing we can do now is try to bypass the validation or try to shift the window and try to raise, to find a raise condition on this. What does it mean? So basically, if you spot the window that you post the content of, what was that? Just a second. So you post the content of exploit PHP, right? And then you get it. And if there is a raise condition, that means that I upload the exploit PHP, and before hitting the extension validation, this time windows, this time frame, I just can't read it. Because this file's avatar's path is publicly readable. So this is the vulnerability that hits here. And let's just do this. So I'm going to send to the repeater this guy, and also I'm going to send this to the repeater, yeah. And here you can create a group. So the notion of the raise conditions that it should run simultaneously, concurrently, I would say in a parallel. And if you create a group, and now let's see, so I try to upload exploit PHP, and immediately I try to get this file. And before hitting the extension check or validation, I can, so this file gets contents, will get back to you as Carlos secrets. That imagine that this is some kind of shell redirect to some port and it gives you a shell access. So just imagine this. And now the same idea. So I upload, but before the validation check, there's a time window. So it's not atomic. There's kind of weird action behind this validation, and I can run a race and win, basically. And if you go for the send, let's just go, for example, send group in a sequence, right? And if we run in a sequence, probably, and understandable, we get here's a vulnerability, here's a validation error. So sorry, only JPEG and PNG files, but it's just because it's sequential. It first uploads and then tries to get the file. But if I run this in a group, in a parallel and a single package attack, let's see what's going on. One more time. I trust you. Wait. Ah, yeah, okay. Wait. This is a getting, right? And how about duplicating this? For example, 10 times. And send group in parallel. Nothing happened. My POC failed. Interesting. Wait. We post it, right? Sorry?
So you load the mountains JPEG?
Not mountains, exploit PHP.
But in the GET request, what do you request?
Yeah. Thanks. That was good catch. So I don't need this. And I need exploit. Yeah, it's always happening when you do live. Then, yeah, probably here we will succeed. Okay, you're not found. Okay, error change. That means it's something that's catchable. Interesting. Files, avatars. We upload it. And then, okay, let's just now increase the, now duplicate the thing. And send group in parallel. Okay. So now we succeeded. So this is a try and error. So you see that it's kind of, you have a chance to get this race condition, but it's also high chance that you're going to fail on that, because you need to spot exactly the time frame, synchronization frame, like time window. So here we spot that the file is uploaded, but until the validation, there is a tiny millisecond, and the race condition run between these milliseconds, and we win. Okay, question can come that how to prevent this. So basically, I have a validation for extension content. I did everything, but something wrong again. I'll make it atomic. So uploading and checking should be in a single unit. So not like uploading, then checking. It's like single chunk. Imagine that this is a single payment processing transaction. If it fails, if it fails. So there's no window to inject to race run. I guess this simple example is quite, I don't know, informative. Yeah? And, but you see how it's critical. It's a different window. It's not like error getting, oh, you uploaded not a JPEG file. It's more business flow. Okay, no questions so far, right? Okay, then cool. Yeah, we are done this lab, so I'm just like on watching what I'm doing. So the first scenario is to find the time window small enough to inject and run a race condition. We are done with the first scenario. The second scenario is limit over run race conditions. So here in this lab, it's a bit different idea. It's applying some kind of discount code multiple times. This is also a usual case, right? When an e-commerce or when any website, they give you a discount code, and you want multiple times, obviously, to use it, but most of the time, it's only one time. Let's just run this. And in this case, it just also read the lab's description. It's also important. So this lab's purchasing flow contains a race conditions that enables you to purchase items for an unintended price. So unintended price, probably like that means there is a like $1,000 laser jacket, and by applying the discount code, you want to buy it for 50. So your ambition, right? You define your goal. And yeah, let's just access the lab and try to understand what's going on. One more time, we need to understand the usual case. Then for the race conditions, you also try to spot this race window. It's important. Waiting. Okay, this is a shop. Going back to our burp suite, I'm gonna clean. Can I close the all? Close. Anyway, let's just hit it here. But we need to clean the history. Try to understand what is this. Okay, going here. If we go to the My Account, and probably it is the same username, and but where's, okay. So if we go to the basket, so it's empty, and for 20% off, we need to use this promo 20. Let's just go for, I'm interested in to understanding how this application acts. And they usually, like, if you view the detail and add this to the cart, and if you go to the, okay, now it shows the discount form. So that means that somehow this application understands that there is something in your basket and shows you different kind of stuff. So it's interesting things to spot when you look at the application or when you build the application. And then the usual case, I'm going to apply this one more time. Okay, it gives you, well, this is a decent amount of discount, I would say, but still we have 50, you know, and we need more. So this is your ambition right now, and okay, I applied it, Then we go to the book suite and try to understand how it's applying works. So it sends a post request to the card coupon, and what kind of data? It sends a CSRF token, and then the coupon name. And then if it's applied, it returns back the message that it's coupon applied. How about one more time? I just want to see what's going on. If you apply one more time, okay, coupon already applied. That means there is some kind of check. Yeah? We are sure that there is some kind of check. So it's not as easy as we expect. If we go back, so we send one more time, and we get back a coupon already applied. This also, yeah, I didn't suspect anything right now, but I dig it more, yeah? And to digging it more, let's just go, for example, what I want here is I have a card, and I have one lightweight leather jacket there. If I refresh this, no, not this. Oh, no, sorry. It just remove it. Like, removes the coupon. I don't want applying. Let's see what is this also. So it sends coupon name to where? So it sends post request to card coupon remove, and basically nothing returned, like informative, just removes the coupon. But I still have the leather jacket in my card. I just refresh it to try to understand how also it gets the data. So if we get sent to the repeater and try to understand, okay, let's just send one more time. And if we explore down, you see there's a card and one addition. What I would like to understand, how it understands that this specific item belongs to me, to my card. This is an interesting part of that. And for that, I'm just trying to remove the session token. Let's see if it understands somehow. Okay, no, 0. What we can predict from here, the card and the item inside it is somehow associated to our session token. And I suspect that when I apply also discount count, it's somehow related to the session. And when it's related to the session, there's some kind of database update, must be, as I understand, behind it, that, okay, this is this user, this is a session. Let's just go and update the status of this coupon for this user. And we have a time frame, so, a window. Before checking the database, you can run it multiple times before hitting the database check. So this is, I don't know. In a sense, like if we put in a simple way. If we get back the session token and one more time run, we can see that the item is back. Okay, to support our, our initiative, let's just one more time apply coupon and get the card. This is a important. So apply and get. Yeah, I'm going to get this coupon one more time and try to apply. And then I need to go to the proxy and get this post and send it, and send it to the repeater. I'm going to repeat this action. But before that, I need to remove it, right? And before that, I need to remove. And then, yeah, probably it's worth to create a group. And then it's worth to duplicate it. I don't know how many times. Let's just duplicate 20 times to see what's going on. If we duplicate 20 times. So we are trying 20 times apply the coupon here and try to spot the race window, this time frame. And if we go to yeah, you just send it in, for example, in a sequence, but a separate connection. I'm just curious what's going on. So coupon applied, coupon already applied. So you see, first is applied and second is already applied because it is synchronized. So it's like in a separate synchronized POT requests. That means I need to go back as I have already applied, and I need to remove it. And let's just, it's still stacked on somewhere. Oh, I suspect, no, not here. That's interesting. So if I refresh, okay, so interesting. It tries to apply in a somehow queue, which is, I don't understand why. Yeah, let's just remove one more time. It's interesting, getting more interesting. If we refresh, okay, if we refresh, yeah, some kind of, you see, usually this is such a simple mistake that we just don't give attention, and then because we don't think that somebody is going to run in a parallel or run in a sequence like 100 times of the things. And this is a single-threaded mind, so that's a problem. Okay. Interesting when it's going to finish. I guess it's finished. Okay. Now, so if we go one more time to this crazy coupon side, so we have 1,000, yeah, and 50, okay. Nothing changed. I was thinking that maybe it's also deducted or give some kind of credit, more credit, you know, as a side bug, but no. It's just running in a single package, parallel. So I'm interested in what's going on. Okay, let's just go back and refresh it. Okay, we get more. So, but it's still not enough because we have 50. So it's getting interesting. I need to remove it and then refresh it and one more time, try. No, not succeeded right now. Okay, let's remove. Refresh. Yeah, I believe we can do it. And okay, this is a chance. You know, it's non-deterministic also. But you see that we got 500 and something. I need to just be sure that we got below the 50 to buy this jacket. Yeah, I want this jacket. This is usually how it's happened, but then you realize that you don't want it because you have no money. And then, please, no.
Can we increase the number of requests?
Yeah, that's a good point. Okay, let's do. So you mean 10 more, right? Okay. And then try to, no. Interesting.
Can you write a program that tries it again automatically?
What?
Can you write a program that tries the requests, and if it's not enough, deletes the coupon code and tries again?
We can write, yeah, but I didn't write it, yeah. Yeah, we.
So can you decrease it to like 5? Because it could be that, like you said, all the requests it kind of overlaps.
Probably. So
Decrease it and see if there's a change.
decrease it to 5?
Yeah.
Okay, let's do. That's interesting. Oh gosh. But wait, there can be a problem because we are applying only the coupon but not getting the coupon. I want to understand this. Yeah, the question was if we can decrease, not question, but advice was if we can decrease the request size to the 5. I need to repeat the things from the auditory, so that's why. You know what, I'm gonna to close all tabs and then do a different thing. Let's just send this to repeater, but also the GET request to the repeater. And yeah, for the same session. And then I create a group. No, creator, where's the creator group? Ah, here. Create a tab group, and I add this with a nice color. And can we, for example, this is a GET request. I want 10 times this request. And I also want 10 times this request, just in case. That's an idea. And then I would like to send a group in a parallel. Interesting. Where? No, it's not. Let's see. What happened? Nothing, yeah? Ah, probably I didn't remove it. Okay. And then, yeah, we got more. Okay, so we have increased also the getting the card details. So one post request for applying the coupon, one GET request for the getting the card data. Either there's some kind of logic flow or collision. But you see the flow, right? I don't want to try more. So you need to, you already understand what the heck is going there. So it's quite dangerous. And to fix this, it's already easy. So one more time, think about your critical sections that as a single unit. So what we mean, if, for example, I have a check for the session, I have a check for the coupon, I have checked that if it's applied or not, all those kind of things needs to be synchronized. So it's a one single shot. You just lock it, do the hack, and get back the result. So we are going to briefly talk about the synchronization primitives, but it's the oldest topic in computer science. Topics in a literature. It's also related to distributed system, I don't know, consistency control, concurrent control, consistent models, and other stuff. So it's like a lot of theory here. But practically, this is it looks like. And it's the logic behind this is totally different than when we're searching for example, for XSS or SSRF, or any kind of other SQL injection, any kind of other attacks. So you need to understand the business flow somehow. And usually, if you are in a team, you understand already what you are building, and then you can ask correct questions if you have a security team. So I suspect, for example, this is something wrong here. Could you please help? Be kind, yeah? Then you will get a reply. So any questions to this thing? No? Okay, then I continue. So I hope it's not boring so far. And also, like, personally, when I attend to the conferences, I really go to the topics where I don't understand anything, because I want to hear something new. So this is a different kind of like mindset. And I see that also the people, it's also okay that I use, for example, these things, let's just listen to the same topic what I used. But it is not, for me, it's not informative. I want to hear. So here, for example, if you first time see such kind of attacks, then you go to your team and then, oh, there is some kind of flow. Maybe we can check or double. Let's just learn more and other stuff, right? Yeah, good. The third scenario, so it's a lot of scenarios that you can bring, but this is called single endpoint race conditions, and itself a vulnerability is this lab's email change feature contains a race condition that enables you to associate an arbitrary email address with your account. Quite cryptic, right? It's a lab description, but in essence, what is it? So you want to change your email, but you want also change others' email, and the confirmation of the email change comes to you. So not, imagine you change your email, the confirmation comes about X person. You want also change his email to you. So this is a vulnerability, the race condition. Yeah, let's just go for it. And so base idea is identify a race condition that lets you, it just closes, that lets you claim an arbitrary email address, change your email address to Carlos. As this Carlos is poor always for these labs, the winner is successful guys and Carlos is who get hacked every time. I don't know why. Access admin panel and they let the user Carlos. So this is, you see the simple task, but if I could change the others' emails, I would just hide myself and live with it for a long time that I got a lot of things to do. So there's no need to delete Carlos and immediately say I was here until that is not your enemy. But yeah, anyway. Then there's a kind of email specifically for this lab, and we are going to access it as well. So let's just access this lab and see what's going on. Yeah. And things getting dangerous and dangerous. It was a simple web shell upload, and it was you lose already money for the coupon, and now you lose your users. So it's like more and more. And I'm going to one more time to our poop suite, and let's just group this back. But I need to already clear the history. I don't need this guy. And okay. Oh, they sell the caution sign. Yes, must need it. Okay, if we go to the Wiener and the Peter, and so we have also the email client. Let me zoom in a bit to others, probably. I had to do it before, but sorry. So basically, your email address is this, and then your inbox now is empty, obviously, but let's just change it. What I would like also change is to change the same. So I don't want to change my email address for now, but I want also to change, to see that how the update email functionality works. So usual case, as we say. Please click the link in your email to confirm. Okay, cool. If I refresh my email, so I got a confirmation. To confirm your email change, click here to confirm. Let's just click here to, okay, your email has been successfully updated. Nothing dangerous, right? It's quite usual. So you confirm, you change your email, all good. Until some guy until you spot a race window. This is important. And let's just explore how the request working. We send a post request for the email change, and yeah, so it has a CSRF token, it has an email as a body, and what else? Nothing special, right? And you have a session. Now, I would like to do this the same, like second time, to understand the uniqueness of the link. So, you know, you update your email several times to understand what happened behind. And then if you send to repeater and I just want to send it directly, probably it works and we got back, wait, I don't need it. And we got back to to our email and hit refresh. Okay. So now to confirm your email change, and let's do one more time. It's just it's interesting how it acts. So we have a 3. And we clicked it. It's already confirmed, right? But how about this guy? This link is invalid. So, but how about the newest one? Okay, the newest one is succeed. So I suspect it only stores the last email, so the last unique token for the email confirmation, and it invalidates the others. So instead of probably appending the request, it just updates the database. And during this update, or before, is a race window, right? Time window. Before getting updated, I can send multiple of these emails and with different data. It sounds cryptic. Yeah, it's just wait. I'm interested in. Okay, let's just duplicate this 10 times, just a case. Yeah, and create a group email attack. Let's just give well-deserved name, and then purple. It's purple or red. I don't know. And then I just want to duplicate. Okay, just 5 times. Let's just duplicate 5 times to make it easy, and keep the winner. Then I also want, for example, to make it test 1, like to make it test 2. Manual work to make it test 3, and test 4, and then I don't know, test 5. And directly, let's just send it as a parallel. No, let's just send it in a sequence as a separate connection. Let's see what's going to happen with our email confirmation. So I just send it in a group and go back to our, okay, if we explore, and one more time. So we sent 5, right? Test 5. Okay. We got test 5 for test 5. We got test 4 for test 4. So it's aligned. You know, test 4 sends for test 4. Test 5 sends for the test 5. Yeah, I really suspect that if I send it in a concurrent manner, it will send test 5 to test 4 for the confirmation. Let's just see if it's true. If it's true, then we can update others' email to ours. Well, I don't know. Have fun with that. So sending group. Let's see. Oops. Yeah. And refresh. So we got test 4. We got a test 3 for test 5. So this is also, you see, this is a simple step. You just send the confirmation email, how dangerous it can be. But now it's turned out, okay, if you didn't do it atomic, or you do this and give the time frame or time window, you can get others' email confirmation to your email. So test 3 was, for example, me, and test 5 was you, and you got updated my email, and you're happy, my account. So it's account takeover, I don't know, you owned, you know, this hackers terminology. Yeah, that's crazy. And I would like to click here to confirm, okay, this link is invalid, but still, it's a dangerous vulnerability. So you expect, what to expect to the email confirmation. It's also related to this MFA. Yeah, you check for the code of the some second factor authentication and your defense layers. It can be related, for example, you have an API rate limit, but you didn't check the rate limit atomically. You just get back an immediate response, or you have 100 requests left, and I just boom you if it's a race window between the check and use your API for example 1,000 times. So I just overrun the limit. This is this kind of attack. Yeah, there's quite dangerous things that we talked about, but as you see, it's a lab, and yeah, probably not all of our applications falls under poor condition like this. But it's important to get how's the taste. This is the thing. This is the core logic behind my talk. So just understand, okay, there is some kind of problem with my code, but I don't know where. It's also okay. So you spot a problem, but you can't understand what is a problem, but it's the first step. You are going to explore, research, understand. And this problem, these conditions, hit Facebook badly in a couple of years ago. There was such a condition that they gave a blog post that it took 8 months to understand what was going. So you are not, I'm not sure if it took 6 months or 8 months, but I'm not pretty sure the length. But there's a blog post from the Facebook engineer. You can also search for that. So it's quite dangerous. No questions so far from auditory. Not from Slido, so it's crazy. As a topic is...
okay, I think we have something on Slido
okay,
now.
cool. Should I continue or you ask a question?
Yeah, just continue.
Yeah, just continue, okay. So we are done with all scenarios, but I also prepared some kind of, I don't know, don't show this code to anybody, but it's a naive way of getting the race condition in a simple actions, and we can exploit it right away. So, and what's it? So basically mimics that. We are trying to, for example, we are trying to update an email, right, as before. And here we have a storage of the email. So user 1 has an email user 1, and user 2 has an email user 2. And basically, I put just the time sleep 1 to give a window, race window manually. But imagine it's a network lag, I don't know, a jitter or a database lag. But anyway, but here it's simplest because it's synchronized. I know that there is a window. I know that there is a sequence that I can run into. But the important part to spot this window in a real world. But usually people is finding this also. So I'm just sending an email with a multi-threaded environment. I am trying to update the first email to new email 1 and the second email to new email 2. And basically, if it's properly synchronized, that means that 1 and 2 is updated synchronously. But how about I need to run this? Let's just run first our application, right? And this is a Flask with all kind of, I don't know, shiny stuff. This is a main Py. But wait. Yeah, okay, so it's correct. Email changed to new email 2 for the user 1, and email changed for new email 2 for user 2. We just updated both of the user's email with the same user. So it was the same thing, that not the same thing, but it's closer, right? It's the same logic. You expect your update function of the email to be used as a single-threaded. You didn't check it in a multi-threaded environment. You just write your code, right? And you didn't expect, okay, somebody will hit your update email hundreds of times, and that's why you are not prepared. This is a problem. So be prepared. This kind of stuff. And if, for example, here, this temporary email storage, accessing the email, getting an email, and updating an email was a single transaction, like single logic unit, there is no time frame to inject. in the middle. It's just, you are secured. It's a black box. It will wait until, for example, one is updated, then it's second. So this is that's called a synchronization. If you read about multi-threading, multiprocessing, and in the literature it's called like synchronization primitives, and you read about semaphore, I don't know, lock, thread lock, and that's why it's called synchronization. What we synchronize? We synchronize access to some shared state. This is the essence of the problem. Critical section. We spot a critical section. For us, the critical section is update an email, right? We defend it, and we exclusively lock it, for example, right? And we synchronize the access. We don't allow, I don't know, multi-thread the concurrent access to my critical section. It's the same as with the database. If you read about the database internals, there's also like consistency models, right? How to make the database consistent. If you have 100 million accesses to the same row, how your database ensures that the data corruption is not like fire. This is the same logic. So the people over decades trying to solve this problem, but we understand that it's needed in distributed systems. We understand it's needed, for example, in a databases. But nowadays also we need to understand it's needed for the web applications. So you can hit badly by this vulnerability. Okay, cool. No questions, and we are go.
All right, we have some questions.
We have questions.
Yeah. All right, so.
Is it hard?
Someone just. Okay. So it says, have you seen any attack vectors that make use of very high request latency of HTTP requests?
Higher latency. This is a problem, not also the HTTP, but TCP itself. So basically, what this burp suite guys did, if you spot the attack thing, so you see there's a single package attack. What they spot that in HTTP2, you can, how to say, stack in one single TCP package a multiple HTTP2. I need to pick the proper terminology, but imagine that you have a single TCP package injected a multiple HTTP, and until there's also like synchronization inside the package until the last bit it gets, TCP doesn't understand that it's done. So this is kind of also a problem. These guys solved this by inventing this in attack vector, but it can be really hard without this tool. But maybe maybe you can use this latency, but I didn't see. Mostly the latency is problem when you try to spot this, spot the race window. So it's non-deterministic. One time it's 5 seconds, for example. One time is 1 second. It's really hard to where to inject yourself. Yeah, I'm not sure that I have answered this question, but I did my best.
Okay. All right. The next one is, how would you start to implement security checks in your code reviews?
Sorry?
How would you start to implement security checks in your code reviews?
That's a good question. So one thing is automated checks for the standard vulnerabilities. So it's kind of imagine there's thousands of kind of standards known vulnerabilities, right? And you need to add this as your pipeline or as your strategy of the check. There is a free tools, paid tools, but you can start to add those static analysis of your code and plus the runtime checks that, for example, I could spot some kind of vulnerability because this library contains this vulnerability. And this also heads to the supply chain problems of the things. If you have a lot of dependencies and you didn't check the vulnerabilities for these dependencies in your project, if one of the dependencies get vulnerable, that means you are in a danger. So supply chain check, static checks, all this stuff are already, how to say, done by others. You need to use the services of this. Plus, if you have like security team, you can inject them as a process of the software development. This also can be important. That, for example, you have a PRD doc, you need to collect the requirements, and you ask for the security research engineers, could you please check my the requirements and my implementation plan? Basically, they will add, okay, for example, your API accepts some kind of JSON, but you didn't check the size of the JSON, for example, right? You didn't check. Okay, you check the contracts, that what kind of fields you accept, but you didn't check also what type of data you, for example, accept. And these things is a different window. The security engineers will put in this doc, and you understand, oh, okay, add this check, add this check, add this check, add this check, and you are pretty done. So you have a 15 changes, and all related to the security, and out of box, you have already covered the most scenarios. Yeah.
Okay, so I think this is done. Can a slow internet connection to a server be used to prevent race condition attacks or make the attacks more difficult?
Yeah, as I said, that unstable. So you need to probe, and then you need to probe. So you need to check where this is a hard part of the race conditions, that where exactly this time slot, like race window, and the network jitter or network problems, I'd say the TCP problem, HTTP problem, I don't know, connection and latency can be some kind of, I don't know, I lose your, so if attacker loses the appetite, that means, okay, this time you are lucky. But that doesn't mean that somebody is not going to gain more appetite against you and come back one year later. So it's not a preventive action, no. Okay.
All right, there's another one says, how does Bob Suit compare to tools like Wireshark and Fiddler?
Wireshark is a network package sniffer, so it's like you analyze a network package. The Burp Suite is for penetration of the web application and an APIs. It has different purposes, so it's different. I can't see that how, for example, Burp can replace the Wireshark. There's also OWASP is a candidate to the Burp Suite. It's also free. By the way, there's also free of charge web scanners that you can inject it to your CI pipeline, so it's just out of box, just in a case. Also, there's kind of automated XSS checkers, I don't know, automated secret checks. This is also important topics, that you don't accidentally push the secrets to the code bases, and then, because there are a lot of companies that constantly getting these secrets.
Okay, just to stick the other ones. For a pen tester testing a set of attacks to a black box target software, how to decide that the attack won't succeed and I have to move to the next attack? I think this is more for a pen tester or something.
Yeah, no, I can reply for this. So basically, imagine that you are a pen tester in a company, and you got a request that, okay, I have API with, I don't know, 10 endpoints, and I need to check it, right? And you need a decent plan on, okay, what is the outcome? So not the output, but outcome of the process. So why I need to check, for example, / some API version 1 and / something? Because I need, for example, it's business critical. This needs to be secure. There's a kind of requirements, security requirements against this endpoint. And then you read it, and you just pass all over and create a report, for example. Okay, during my exploration for this endpoint, this requirement, but it's failed. And then you have a clear outcome. And it affects the business directly, then it has a severity high, and people jumping and trying to fix it. So it's just a chain of the process, not a single.
Sure. Do you know any examples of the limitless discount hack for big amounts of money?
What? Sorry?
So is there like an example? Have you experienced any kind of example concerning this discount kind of hack?
Yeah, sure. My next slide is all about this.
Oh, okay.
So real hacks.
Okay.
How people did it and got the money. So I'm going to show it.
All right. Thank you.
I was expecting this question.
Do we have any other questions from the audience here?
Yeah. Are you happy? Yeah. Okay.
Okay.
You
can go on.
So there is a special GitHub repository for top race condition found vulnerabilities, and the people got money bounty. So it's real hacks, and you see a lot of them. So it's not the like toy, as I did. It's not a toy project to hack. That people really got hacked and lose a massive. Yeah, let's just read one by one. So I just bring 3 of them because I think they are important. So race condition allows to redeem multiple times gift cards, which leads to free money. So is this the answer to the question? I guess yes. And it has a severity of high. Let's just zoom in. And the weakness is called business logic errors. So it's important to read also categories for this report. You understand, okay, race condition, you hit in a business logic. This is most critical thing. If you have a flaw in a business logic, you're going to lose money, reputation, I don't know, any kind of stuff, right? And I have found a race condition vulnerability which allows redeem gift cards multiple times. This is how he can easily buy stuff just buying one gift card and redeem it over and over again. Let's see to the screenshots. So this guy buy a $25, but also use it as $175. Yeah? This is the ambition of it. So one gift card and 7 times more. You can see that he is also showing that the succeeded responses, also from Burp Suite. And also you see that, no, not this one. You see that like bucks and 175 bucks instead of 25. So this guy's got hacked, and the reverb.com, it was in 2019, not too old, so it's usual. And disclosed in 2020. Disclosed, that means it's fixed and there's no vulnerability anymore. And here you can read the discussion. It's also important to read the discussion. Why? For example, I am an attacker or bug bounty, right? I found the thing, I filled the report. But it's important also to read the response from other side, from the security team of this company, how they react. So there's a lot of plenty information that they try to explain that why you hit it, it's also critical, or why they think, for example, it's not critical and they don't give you a bounty and other stuff. But usually, if you spot a race condition, it can have a higher vulnerability, a higher severity. The second one. The second one is medium, but it's also category, the very important, the concurrent execution using shared resource with improper synchronization. This is it, how's the definition of the race condition for this company or for this team. So race condition for them at this moment is somehow there's a shared resource, but it's not properly synchronized, the access to this. And that leads to vulnerability. Race condition in performing a test allows duplicated payments. You see, they lose one more time the money. You duplicated the payment. That's important. And here, for example, this guy observes that 500 payment was sent from HackerOne 2 weeks ago. An impact is, given that this went not, and 2 weeks, okay, in 2 weeks they lost a lot of money until they disclose and close this vulnerability. So basically, the logic is, if if this guy clicks retest payment, so what is a retest payment? So you have found a vulnerability, right? And you got a bounty, for example, $5,000, and the another side, the company fixed the vulnerability and now requests a retest from your side. So you should confirm that it's fixed. So this is a retest payment. And they pay extra for the retest because it's not a part of your original bug. It's already fixed and you need to get extra money. And then you request several times the payment and then you get the payment. And yeah, instead of 100, you get 500. And then they resolved. It was 2018, and it's resolved immediately, one day. Not 1 day, no, what? Wow, it's 2 months. Okay, anyway, they live with that a lot. Probably, I don't know, I'm not sure that why it gets, for example, what they can prevent, they just temporarily close the retest payment until they fix it, because it's not an original payment. It can be closed, for example. I'm not sure how they mitigate it. So you see that it's a concurrent execution using shared resource with improper synchronization. Amazing. The third one. The third one is interesting. Also, race condition leads to undeletable group member. Imagine you have some members that you cannot delete in your application. And okay, it has a severity low. I guess why? Because you need to be a valid member anyway. So it's not an account takeover, or it's not a true hack. But I am a member of your company, but I add myself as a non-deletable member. So you cannot remove me. This is funny. And this is a discussion. Okay, there exists a race condition, which is the user can add themselves twice to a group, which will make them unremovable from group. And when first time, imagine that you're as a software engineer or developer, and you read it, yeah, report. How? Your first question, how? How you did? Because you were not prepared or you are not aware of such kind of things. This is important, like being informed of something. And it's closed pretty late, but I'm not sure they give a bounty for it. And time of the weakness is TACTO. It's called TACTO. Time of check, time of use. Basically, if you search for that, it's a simple thing that, okay, at the time of the check and the time of the use, there's a kind of window, and I can run the race there. This is important. Yeah, so good so far. No questions? No. Okay, I have 10. Okay. Yeah, cool, I have time. And a few things that, okay, you understand what is this, and you also want to dig deep on the topic, but I would suggest, for example, try to understand the documentation about the concurrent execution. So the concurrent execution, concurrent models, consistency models, and other things that are related. So you can read the literature, understand the core problem, and then you act. And then you see that it's a primitive, for example, lock objects. Just read what is a lock object. Now the synchronization is clear. What is a synchronization, right? We synchronize the access. And the lock is a primitive, lock is a synchronization primitive that is not owned by a particular thread when locked. And each language has its own implementation. So concurrent model of Python can differ from the concurrent model of the Java or of the C# or Golang. So you need to, okay, I'm not suggesting to read the Java and to understand their concurrent model, but if you are interested in the thing, in the topic, you can compare the implementations and understand what's going on behind. This is one thing, it's important. Also, there's a special research areas called, as I said, concurrency control, consistency models, under the umbrella of distributed systems. So if you read about distributed systems, nearly all of those topics are related to synchronization. So how to make, for example, 5,000 machines to talk to each other without breaking each other. And then let's go and start. So there's a ton of books you can explore. What is it? Yeah, I'm pretty much done for this tutorial and the talk. I don't know, and this is me. Thank you very much for coming, and this is my contact. Let's contact on Twitter, LinkedIn, GitHub.